So fifth graders, today is October 10th, 2019, and we are doing Module 2, Lesson 6. Okay, so this week, tomorrow, you will have a weekly check-in that will cover Lesson 6, 5, 4, and 3, the 4 lessons we did this week. Today's learning goal says, I can explain how an area model represents the distributive property of multiplication. So as you know, we've been talking a lot about area models this week and using area models as one of the many strategies we have to multiply numbers. Today I want to show you how when you do the area model, you're really just doing the distributive property. We have talked about different properties of multiplication before. We've talked about commutative property, which says I can move the order of the numbers around. I can commute them from one position to another, and it doesn't change the value. We've talked about the associative property, which means I can change who I associate with using parentheses, and it doesn't change the value. We've also talked about the distributive property. The distributive property says if I give something to someone, it's only fair if I give it to everyone else, right? Okay, so if we have a problem like this, 18 times 32, is 32 the same thing as 30 plus 2? Yes. So I could split up 32 into two parts, a 30 part and a 2 part, right? So then if I'm going to multiply, I have to distribute 18 times 30, and I have to do 18 times 2, right? So what the distributive property says is that 18 times 32 is the same thing as 18 times 30 plus 18 times 2. Do you guys agree? Yeah. Okay, good. I want to make sure this should be review, okay? Today we're going to see how this is represented by an area model. Are you already starting to see clues of how it might be the same as an area model? Yeah. If not, don't worry, you will. Today the directions are similar to yesterday. It says to draw an area model, then solve using the standard algorithm, and then use arrows to match up where those partial products show, okay? Now, we have 64 times 73. Today's area model looks a little bit different than yesterday's area model. What's different about today's area model compared to yesterday's area model? Allie?
It's split into 4 parts.
Yeah, yesterday we only split it into 2 parts. We only split it horizontally yesterday. But today, I thought, well, if we can split 73 up into 70 and 3, why can't we split up 64 into 60 and 4? It'll make our work a lot easier because then we really have to think about math facts only, okay? So go ahead and set yourself up with this area model. So again, remember we split it up so that we only have to think about math facts. Okay, we split it up according to place value. So we know that 73 is the same as 70 plus 3, and we know that 64 is the same thing as 60 plus 4. Do you guys agree? What is the length from here to here? 70. What is the length from here to here?
60.
60. So how do I find the area of this red portion?
7 times 60.
Okay, so we can think to ourselves, what's 7 times 6?
20.
And then how many factors of 10 do we have there?
2.
1, 2. So I add 2 factors of 10. So 70 times 60 is 4,200. What is the length from here to here?
70.
70. It's still 70. It doesn't say 70 right next to it, but I know that if from here to here is 70, then from here to here is still 70. Do you guys agree? Yeah. What is the area from here to here, or the length from here to here?
4.
So how do I find the area of this blue part?
70 times 4.
Good. What is 7 times 4?
28.
And then how many factors of 10 do I have?
1.
Good. What's the length from here to here?
3.
3. What's the length from here to here?
60.
Good. The trickiest part of using these area models for kids usually is not doing the multiplication. There's 2 tricky parts. One is finding out these lengths when the number isn't written right next to it. You have to look above or below or left or right to see if that same length is listed anywhere else, okay? So how do I find the area of this blue part here then? 3 times?
60.
Good. What's 3 times 6?
18.
And then how many factors of 10 are there?
1.
So 180. Okay, last but not least, what is the length from here to here?
3.
What about from here to here?
4.
So how do I find this part?
3 times 4.
Good. Another typical mistake that 5th graders make is that they forget about that last red small square section. Okay, because do you see how there's no measurements listed here or here? So they forget to do this one. Don't forget. Okay? Okay, so how do I find the total product? How many partial products did I find already?
4.
So how do I find the total product? I have to add them all up, right? But before we add them, let's do some standard algorithm, because remember yesterday the partial products should match up. So let's see. What's 3 times 4?
12.
12, okay. What's 3 times 6?
18.
Plus 1?
19.
192 is our first partial product. Which one of these is 192? None of them. I have 4,200, 280, 180, 12. What mathematical equation did we do here to get 192? 64 times 3. Where on our area model is 64 times 3? Well, look at this. Here's 60. Do you guys agree? There's 64. Do you guys see that? Times 3. So is the area of this green section, what are the partial products? 180 plus 12. So what's over here? Let's write 180 plus 12, which is 192. So there's that partial product. Do you guys see that? Okay, does that make sense? Let's move on with our standard algorithm. Now that I'm done with the ones, I need to put a placeholder 0, right? What's 7 times 4? 28, okay. What's 7 times 6?
42.
Plus 2.
44.
So what's that partial product? 4,480. Oh, okay, well let's see. Didn't I do 64 times 70 to get that? And this top right here is 64 times 70. So if I add up my partial products of this top part, the total area of that top part is 4,200 plus 280, which is 4,480. So draw an arrow, there's that partial product. So now, to find my entire product, I have to add these two partial products, 4,480 plus 192. That's the same as adding this, plus this, plus this, plus this. Do you guys agree, my 4 partial products? When I add that up, what do I get?
4,672.
Yeah, 4,672. So the total product is 4,672. Okay? So how does this relate to the distributive property? Well, I split this up, I split 64 up into 2 parts, 60 and 4, right? And I split 73 up into 2 parts too, 70 plus 3. Do you guys see that? 60 plus 4, 70 plus 3. Yes? Then I had to distribute each part to, I had to say 60 goes to the 7, and 60 times 3. 60 times 70, 60 times 3. Do you guys see that? Then I had to do 4 times 70. Do you guys see where 4 times 70 is this part right here? Right? 4 times 70, and then 4 times 3. 4 times 3. Whenever we do the standard algorithm, we're taking one factor, the factor that's on top, in this case 624, and we're multiplying it by each place value digit at once, right? We're doing 624 times 2, and then later we're doing 624 times 80. If there was another digit, we would do 624 times whatever's in the hundreds, right? So each partial product is because it comes from one of the place value positions of the second factor, which is the same thing as the area model. Make sense? Good.